Good morning, YouTubers. It's been a while since I've done an electrical video. It has been crazy busy. This data center work has really been taking off, and yeah, it's been nuts. So finally, I've been wanting to do one of these for a few years, but just have been learning how the systems work, learning the different ways of installation, and just understanding these battery storage systems. We've done, at least 5 or 6 of these projects so far. It's kind of a new industry. It's been around years, but it's still new from like an engineering standpoint. So every job is different and how it's designed, from the foundations to the wiring to really everything. It's still an evolving industry. It has kind of slowed down standardization wise. So like kind of the main layouts are kind of the same now, but still a lot of changes, a lot of evolution, a lot of technology is still being injected into these systems to make them change. So this is the information I know at the time of this video. I won't be moving around a whole lot like before, just because I have a lot of blurring to do. While, because these technologies and these little tweaks are still being made, everybody's very sensitive about their equipment. But generally, they're all the same. You've got a battery, which you see here on the left side that you're staring at right now. And then you've got an inverter, which sometimes they're external and sometimes they're internal to the batteries. And then you have an AC transformer that steps up whatever voltage it is coming out of that inverter, coming out AC, into the transformer up to a distribution level voltage. Obviously, in this case, you can see it's 35 kV. That's pretty standard. And that's just getting the voltage up so you can get your amps down, so you can get your amps and your power to the substation without having a ton of cables, right? More amps is more cables, low amps is smaller cables. So it's kind of the most efficient way to do it. So in this particular case, you have 2 batteries. We're looking at one, and in the center of the screen, right there where the crack is, that's the second battery. So you've got 2 battery banks with an inverter that's integrated into the skid that you're looking at. You've got down low the cable tray. Those are where the 480 volt cables come out into the secondary side through the transformer and out 35 kV. So from there, we will get a little closer. So as you can see, these battery skids are placed on screw piles. We've seen these from long, narrow concrete foundations where there's 1 to 3 per battery, to screw piles like this, and also to the vibrated plates where you just vibrate I-beams into the ground 20 feet. So different foundation designs based on the soil situation they're in. So once these screw piles are screwed in, usually they screw in until they reach a certain torque, and that means that they are good. Then you have to come back with a laser level and cut off all of the screw piles that stick up, level them out, and then you have to weld the plates on. Those are the plates that you see here. Are these batteries going to go anywhere? No. These things are anywhere between 70 to 100,000 pounds. Tons of batteries. I will list out all of the different types of batteries, but there are a lot. The main ones are kind of lithium ion, but there's more. I'll list them below. So that is still changing, what works best, right? But inside of these doors are just stacks of batteries. They kind of come in kits to where they will slide in and slide out, kind of like a breaker where you can rack it in and rack it out. Same type situation. You bring almost like a cherry picker out here in front of the door, and you pull them out and you lift them up with the cherry picker and you can replace them. So it's kind of like a modular system. I don't recall how many batteries are in each of these, but it varies per manufacturer, right? But batteries. I'm not going to show some of the labeling. More batteries, and in this particular case, the inverter is right here in the middle between these 2 cabinets. So these come out from the inverter, and these are simply just little cable trays, but there are, I want to say, 21 total sets of cables in here, and it's 480, 600 volt cable. I believe it's 750 aluminum, and all of that power, AC power then, goes in the transformer here. I'll get into transformers next, but you can see the line of them. So from the substation, which is down there on the other side, we've got a number of feeders, and I think there's three or four on this row. And what they'll do is they'll pop up to, say, the first transformer down there. Then they will daisy chain from transformer to transformer and gather up that power from each transformer. And once you hit the maximum rating of that cable, then that's where the next home run starts. And then it goes into another 4 or 5 transformers. Then the next one starts. The next one starts until you get to the very end. So I believe that there's 3 or 4 circuits in this particular run here, bringing power back to the substation. This particular customer is very tech savvy, so they have added a lot of extra equipment in this transformer. So generally, transformers are a dumb device. There's no electronics installed in them or on them. It's simply windings and a coil, and that's how you get your transformer. This is a little bit situation. They have added items. They've got, let's see here. You've got your oil level switch is attached to normally open, normally closed circuits. So if the oil level reduces down to a certain point, it will automatically shut off. They have monitoring in here. They have I think 735 SEL relay, which will gather individual power data from each transformer and send that data back to the house. That is not normal. It's not really necessary, but it will actually give you power and power quality data for each set of batteries. So it's very advanced amount of monitoring. You don't need that much monitoring, but they want it. And if you want it, you can get it. So there's a 735 relay in each of these, which records your voltage, records your amperage, phase angle, total kilowatts delivered, power factor. There's a ton. What else is in there? There are also emergency circuits coming from the batteries that will talk to the relay here, and then that relay will again send that signal through to the substation to say, hey, I have a problem with one of my batteries, open me. And so that circuit will open, which will de-energize the inverter. But you notice I did not say de-energize the batteries. You cannot de-energize batteries. There is stored power there that has to be discharged somehow, and that's kind of different. So what this will do is turn off the inverter. So it'll at least isolate anything that's going on from that battery back to the substation. But if there's a problem with the batteries themselves, they will burn up. They will burn up the entire skid. They will burn up other skids around them. So how do you not prevent that, but how do you know if that's happening? Well, you've got these sensors on all these fences. And on these sensors, there are cameras and there are thermal cameras. They're not cameras where, like you see, like FLIR, where you look and see the cop helicopter looking down at people with a thermal camera. It is that, but it's not really viewable. And let me explain that. So there is a optical sensor or thermal sensor on these thermal sensors, and they are programmed to see heat coming from certain batteries. So if that camera sees heat coming from, say, that far battery, it will say, hey, that far battery is burning up and we need to do whatever we need to do. That could be shut off all the batteries, shut off the whole farm. That could be shut off the farm and call the fire department. It's endless. But that system is programmed, and they have to test everything to show a heat source for each individual battery. So if one particular battery is heating up or is on fire, these cameras will read that information and know exactly what battery is on fire. So it all had to be tested here. I didn't see that testing, but I imagine they've got some sort of heat source. They'll stand on top or around the battery and ensure that that sensor is picking up the correct battery and sending that data back to the house. And you've also got your security cameras on the outside. I would have mounted them differently. I would have mounted them 90 degrees out. That way you could look inside and outside. Well, I guess you can still look inside, but I take that back. From right here, you have a blind spot with this camera because it's behind the pole. But, duh, that camera eliminates that blind spot. So these cameras can look inside and outside. I don't know if they're automatic. Say the thermal sensor picks something up and those cameras will automatically look at the batteries. I don't know. You could probably do that. So there's really not much to this. It's a repeat of the exact same thing. Same with solar. It's just a ton of solar panels. This is just a ton of batteries. And yeah, rinse and repeat. These are getting pretty big. A 20 megawatt plant used to be considered pretty large. Now they're 3, 4, and 500 megawatt hour sites. This one's a 50. So they're getting big, but it's really a repeat of the same thing. The only thing that changes would be the size of the substation and the amount of feeders. That's about it. A lot of electronics in these things. I don't even know all of the capabilities. But again, they've got sensors in the transformers, sensors in the batteries. Everything talks to each other. And this is probably the substation and battery yard with the most advanced technology I've seen. What's interesting about the substation is this is the first time I've seen a substation with no local control, 0. You cannot open a single breaker, close anything. It is all done remotely, 100%. That's the first time I've seen that. So there are no switches, there are no buttons. It's all servers and relays and nothing else. So they've got a remote center that will operate these.